Hello viewers, I am Jaymin Desai, lecturer in Plastic Engineering, Government Polytechnic Valsad. I and my team members Sri D.P. Trivedi, Sri N.S. Shah and P.N. Parikh has prepared this video lecture for 4th semester plastic engineering students. The topic of the video lecture is polymer composite. Now, what is polymer composite? Polymer composite is a new material which are developing from mixing of two different materials. The basic material will be polymer and we are adding some extra material to enhance the properties of the basic materials. Growing industrial activities create a continual demand for improved materials that satisfy more specific requirements such as higher tensile strength, thermal conductivity, heat distortion temperature, lower thermal expansion, lower cost. Above requirements, which often involve a combination of many difficult to attain properties, can often be satisfied by utilizing a composite material, which constituents act as a synergistically to solve the needs of the application. Definitions of composites. Composites are multifunctional materials systems that provide characteristics not obtainable from any discrete material. They are cohesive structures made by physically combining two or more compatible materials different in composition and characteristics and sometimes in form. Begenzen defined as the composites are compound materials which differ from alloys by the fact that the individual components retain their characteristics, but are so incorporated into the composite as to take advantage only of their attributes and not of their shortcomings. Now, composites can be explained by two different methods. Composites can be classified in metal matrix composites, polymer matrix composites, ceramics matrix composites. Composite material consists of two phases. It consists of one or more discontinuous phases reinforcement embedded in a continuous phase matrix. Composites can be classified into three categories: metal matrix composites, polymer matrix composites and ceramic matrix composites. We will focus on polymer matrix composite, which is subdivided into fiber reinforced polymer and particle reinforced polymer. Advantages of composites: tensile strength 4 to 6 times greater than steel, 25 to 50% weight saving than metal, corrosion resistance is outstanding, fatigue and fracture attributes are numerous, impact and damage tolerance characteristics are excellent, less noisy and lower vibration than metals. Like metals, thermoplastics have indefinite shelf lives, low thermal expansion. Composites tooling is 2 to 5 times cheaper. Polymer matrix composite can be subdivided into fibrous composites and particulate composites. This is the figure explained about fibrous composites. These are the 4 figures in which various fiber patterns are shown. In this, the fibers are arranged randomly. In this, bias fiber arrangement is there. In these, fibers are arranged as unidirectional movement, and in this particular 4th figure, the fibers are laminated between the two layers. The fibrous composites can be made by different techniques. This is the technique of hand layup, in which the fibers are arranged manually and polymer is sprayed over the fibers and the structure composite structure is prepared. This is the pultrusion technique, in which the fiber is passed through a polymer material and the fiber is then pre-impregnated to give the fibrous composite. The various fibers used in composite manufacturing are glass fibers, carbon fibers, natural fibers, aramide fibers, boron fibers. The use of particular fiber will depend upon the end use application. The application may be aeronautical applications, automobile applications or customer friendly applications. The second method is particulate composite, in which 3 types of particulates are used: general particulate, flakes and field or skeletal type particulates. This is the method by which the particulates are embedded in the resin structure. The particulates are added into hopper mixing with polymer material. In with the barrel constitute mix the material of polymer and particulates, then they are stretched by the pullers and finally, they are cut into the granules. Various particulates used in composite manufacture are hydroxides, silicates, oxide, salts, polymers and carbon. These various forms of particulates are used for manufacturing various composites. Advantages of fillers. In earlier slide I have mentioned particulates. Particulates are fillers. They are used to add rigidity, stiffness or hardness, regulate thermal expansion and shrinkage, improve heat resistance, improve or regulate electrical characteristics, increase strength and reduce creep, modify rheological properties, add processability, modify appearance, alter density, lower cost. Making of composite, how composites are manufactured. I will explain in next slide how composites are manufactured. I have taken example of ABS material as a matrix material. ABS is nowadays used in automobile applications. This is the structure of ABS and the granules are seen in the slides. Why ABS is selected for this composite manufacture? Superior processability and appearance, high impact resistance, good dimension stability at elevated temperatures, high strength and rigidity, good chemical resistance, good stress cracking resistance, can be easily vacuum metallized. The main reason of ABS is it is highly costly material, and that is why I am using filler to reduce the cost of the ABS material. This is the Sanosphere, which is used as a filler in the ABS matrix material. Sanosphere is a lightweight inert hollow sphere made lightly of silica and alumina and filled with air or inert gas, typically produced as a byproduct of coal combustion at thermal power plants. It is obtained from fly ash, which contains 1 to 2% of Sanosphere. The thickness of Sanosphere walls may be very small, less than 10% of particle diameter. This is the basic properties of Sanosphere. It is a spherical shape, inert, high melting point, lightweight, free flowing material, insulating material, low water absorption. Now, this is the method how composite are prepared. ABS material is pre-dried at 85 degrees centigrade for 2 to 3 hours before compounding. ABS Sanosphere composites were prepared by using co-rotating twin screw extruder using temperature range 220 to 230 degrees centigrade. The material coming through die is cooled by cooling bath and proceed to granulator unit. The granulator converts the extruded material in granules. This is a short schematic view of composite preparation. Here is the ABS granules, which is mixed with Sanosphere. They are compounded in twin screw extruder and it is converted into granules. These granules are used for making plastic products like in automobile applications or in household applications or in aeronautical applications. And this is the video how composites are made.
इसमें डाल देंगे इसके बाद ये ऑयल होगा ना हाथ से करना पड़ेगा ये हो जाता बहुत देर तक फट नहीं जाए हाँ नहीं बाकी साहब ने उन्ना थोड़ा
बोलाने देखते हैं ना
वारंटी लेके आए हुए रोहित को मजा आता है बनने में हैप्पी बर्थडे इसमें थोड़ा एक बार वो डाल लावा वो लेके आओ। सही चल रहा है। सर आज कलर दूसरा है तो 40 में क्या होगा? ब्लैक तो होगा ही।
This is a video which shows the composite preparation method. ABS material and senospheres are taken in various compositions. They are mixed and they are put into the extruder. Extruder compounds the material and converts into granules by various heating techniques. Viewers, in this video lecture, I will explain various composite preparation techniques in which I will explain the use of ABS polymer and senosphere material by which we have prepared the ABS senosphere composite. I am very much thankful to Government of Gujarat, Commissioner of Technical Education and NITT TR Bhopal for producing this video lecture. Thank you.